the end of my training materials for this afternoon session. I will catch it up this evening. But what I want to now focus on, we've been looking at the individual commands of the bash shell. Okay. What I want to focus on now is bash scripting. Okay. So putting things together into a collection of commands and control flow. Variables, commands, control flow that can give us a reproducible little tool that we can use to do our jobs. Okay? And the example that I will be focusing on is something that is, I think, quite a common task for us, which is where we need to fetch sequence data across the internet. Okay? Even if we are doing our own sequencing, we are often fetching things between computers, and we often are fetching sequence data from the public sequence databases because we need to either test a tool or we need other data to put our own generated data into context, you know? So, yeah, and with that in mind, you know, the job of fetching data is a good illustration of a task that we do very often. Okay. And so if you do, let me see, where did my shell go? So let me just move that over there. If we do ls, oops, sorry, let me just delete this as part of. In your in the directory that we're working in this morning, you'll all notice that there's two new files. File list 1.csv and file list 2.csv. Okay? So we're going to focus on file list 1 for now. Okay? And this is what file list 1 looks like. Okay, so it's a list of sample IDs followed by URLs. The sample IDs are repeated twice because the URLs are for read 1 and read 2 of FASTQ sequencing data. Okay, everybody should be logged back in to the lesson server. If you're having trouble logging back in to the lesson server, to the shell server, can you please put up a yellow sticky or something like that? But we should all be logged back into the server that we were in this morning, okay? But I'm going to be talking about theory for quite a while before we get into the practice this time around, okay? So this is the data. I've reused the course website. I've reused the course website as a place to put this is green or yellow. That is green. Okay. I really will get better sticking through. Okay, so I've reused the course website as a place to put data, which we'll download from later. But here we have all of these FASTQ files. Okay. But before I get into fetching them, I want to get into the theory of the shell and shell scripting. Okay? The first part here is variables. So there's two types of variables in the shell. The first type is not a type that you set for yourself. It's the environment variable. Okay? So the environment variable are things like home or path that get set for you by the shell. Okay? So these are set in your so-called environment. They are there already when you start using the shell. And it doesn't really make sense to reset the value of home because your home directory is not going to move around. Okay. And you can get a list of these things, but that list is somewhat confusing because it's long. By just sorry, wait a minute. If you type the command env, env, you see you've got so many environment variables, but you see there's many of them, and honestly, even I don't know what some of these things are for. Okay, so we'll just focus on them as we need them. So, for instance, path that tells Bash where to go look for programs, or home that tells Bash or tells you where your home directory is. Okay, so those are environment variables. The other type of variable is a user variable. That's one that you set for yourself. Okay, and these variables are designed to be used either in the same session where you set the variable, or they are being used in a command that you are running in your shell session. Okay, but I'm going to focus on the ones that you set for yourself. We set them quite simply by saying variable name is equal to value. Variable names have to start with a letter, but can also include numbers and a few other special characters like underscores. Okay, so that's a variable name for you. Okay? And then they retrieve using the dollar. So if you've done the intro to shell, you will have seen this kind of stuff. So you can say echo and dollar and then the name of a variable. And this is true for environment variables as well as variables you set for yourself. So here, we can see that the value of the variable called home is /home/user50. It'll be different for all of you because I'm user 50 and you are different users. Okay? So, the variable that you set for yourself, like for instance, var is equal to value, notice that there are no spaces here. If I say var is equal to value, it thinks that var is a command. If I say var equals space value, it thinks that value is a command. So var is equal to value, all one thing, no spaces. Okay? Having set it, I can now get its value back. And there its value. Okay? The other way to refer to the same thing is to put it in curly braces. Echo, dollar in curly braces, var. It's the same thing as saying echo, dollar var without the curly braces, but why is there a difference and why does it matter? It matters when you want to when you want to use the variable together with other things that might get misinterpreted. Okay, so if I say echo var with the curly brackets, it says value underscore name, because it recognized that the bit in the curly braces is the variable name, and then underscore is outside of the variable name, and it uses this just as it's just going to echo the variable name and then underscore name, and it's just going to be like so. Okay, but if you don't have those curly braces, now what's happening now? Why did it do that? It looked at everything as one variable name. It's looking for a variable called var underscore name. So now if you've used a language like Python, you try and use a variable and that variable is undefined, Python's going to give you an error. Okay? But in general, the shell doesn't do that. The shell will just happily use a variable name that doesn't refer to anything, and it will just say, oh, there's just nothing called that, and it'll give you a nothing back. Okay, so why you get this blank line? So that's why the curly brackets are for. But there's a lot more that you can do here. So, sorry, unset. Just, if I say my var, if I now say look at my var, and I've unset it, so it's not equal to anything. But inside of the curly braces, magic can happen, okay? So what this is saying is that there's two parts to what I'm saying here. They're separated by a colon and a hyphen, okay, a dash, okay? And the first part is the name of a variable. The second part is a default value, okay? So the default value is the value that you will use if that variable is not set, okay? And because my var is not set, it says hello. So this is a bit of a silly example. Let's make this a bit more real, okay? So if I say num is equal to 10, okay? And head minus n $num cases.csv, it gives me that number, okay? Now I'm going to unset num. If I now say, how many lines do I expect to see if I say like this? Remember, num is now not set to anything. This expansion, what will this become equal to? Sorry? A 5. It looks almost like, because of this dash, it looks like it'll become -5. It's not -5, it'll become 5. Because these two things work together, and this thing will give us 5 lines out of that file, okay? So if you've got a place where you want to use a variable, but you don't know if the user has set it or not, okay, then you can use this to get a default value, so that there's always some value, okay? Another place where I've seen this used a lot is when somebody wants to say, how much resources does a program need? Sometimes the bioinformatics programs that we use, you can choose to run them with 1 CPU or 4 CPUs or whatever it is. I've seen this used to say, set the number of CPUs to, and give it a default. Default is maybe 1, but if the user sets the environment, sets the variable to something else, then it'll use this different number, okay, that's in the variable, okay? So that's having a default. The next one is an example of a pattern manipulation of variables. So if we took this example that I've used in the notes, my var is home user Patrice, okay? So if I go echo my var, then I get the full value of my var. But now, for those people who know sed, know that I could use the command sed to change the value. But I can use the bash shell as well. If I say, if I say this, remember what the original my var is? Notice the hash, the single hash symbol over there, okay? So what this does is it says, look up a variable called my var, but only show me the value after the first match of that pattern. So you see there's a pattern called */, okay? Now star can stand for anything. It can also stand for nothing. So if you look at home user Patrice, */ matched the first slash. So it pulled that off, and it gave me the rest of home user Patrice, okay? Which is home user Patrice without that slash at the first. So if I want to just get part of a value out, I can use this. In the notes, I also put a link to the GNU Bash manual, where it shows lots of other ways that you can manipulate things, but I'm going to show the ones that I think are most useful for shell expansion, okay? If I replace that single hash with 2, then what it does, because you see there's lots of places in home user Patrice where the pattern / can match, because it could either be the first slash or / could match home / user / it could. There's also the last slash, okay? If I put 2 hash signs here, what I'm saying is give me everything after the most that this pattern can match, okay? The first one was the least that it can match. And we get here simply the word Patrice out, because the most that / could match there from the start of the line was everything up until /home /user /. Okay? So effectively what I've done here is pretty similar to if I did base name. The base name command gives me just the name part of a path. Okay? But I've done it using a built-in capacity of the shell. Okay? I can work from the other side of the variable as well. Sorry, I meant to not use that one. I meant to use this one. Notice that I've changed my pattern from / to /. Okay? Now what I want to know is give me everything until the last place where / can match. Okay? So here it stripped away the last / because you see there, if I did this with so not / okay? If I do this with 2 percentage signs, it will remove everything from the first place that / matches. Where is the first place that / matches in home user Patrice? Right at the start, eh? So if I use this, it actually eats the whole thing, because the first place where / matches is the first slash, okay? So if I say here, let's just everything E star, then it removes everything from the first place where E star matches. Okay? These little things like this, they become very useful when you've got a value and you want to pull out part of a value based on a pattern. We will see that a little bit later. As I said, there are actually more things that the shell can do than this, but these are the ones that I find most useful. One last thing, I want to add this to the notes, I forgot to mention this, is that all of these variables only live in this shell session, okay? So if I say my var, there is my var, okay? But if I start a new shell, bash, I'm now in a new shell session. This, I'm using bash as an example, but any program would do here. Okay. If I start any program, does it have access to my var? Let's see. Nothing. Okay. Unless if I tell my shell session that I want to add my var to the list of shells that get of shell variables that get exported to each command. Okay. Exported means that the next command that I run also has access to that variable. See? If I say export my var and I start a new shell session, you see there's the value of my var. Just to be clear what's going on here, when I say bash, I'm already inside the program bash. When I say bash, I'm starting a new bash shell inside of the bash shell that I'm in, okay? This is, not something you do often, but if you think about this, when you run a program, even if you write that program yourself, like maybe it's a Python script you wrote or a shell script that you wrote, you will only have access to those variables in the environment that have been exported. If you don't export it, it only lives where you defined it. Okay? So this is about the life cycle or the scope of the variable. Okay, that's what the export command is for. And so you might sometimes see people make a change to their path environment variable. Remember, the path environment variable is where the shell looks for programs to run. Okay? And if you make the change to the path environment variable, but you don't export it, then something else that you run will not be able to find that thing that you just added, to use that directory you just added to path. Okay, so it's about like these life cycle things.
Peter,
yes.
I'm just trying to understand the one with the percentage.
Percentage, yes.
Is that meant to say that comes before the last estimate?
So it's a 1% or 2%, or 2%.
Okay, so the one with the hashes, they're supposed to say that it prints the particle variable after the first estimate.
So the percent takes things away. Okay. So effectively you can think of it as taking it away, right? So the one with the hash basically does so if we take, like, for instance, if we did this with a hash, then they all can take things away. Then
I feel like the one is everything before and the other one is everything after.
yeah, it's kind of like that. So
Both of them say after.
because I changed the pattern halfway through my examples.
Okay, so the last two is meant to say before.
No.
Because it's printing everything before the last.
Look carefully at my examples, okay? It comes after the last pattern match, okay? Right? So here, actually, no, you're right. I think this should be before. Because that will print, no.
The last pattern match is the last slash.
Okay, yeah, you're right. But, sorry, I'm struggling. The English is wrong here.
Yeah.
But it will come. I will correct that. Okay. I must admit, every time I'm using percentile and hash like this, I do a bit of testing before I use it, because every time I do actually have to remind myself which way around. I know that it's there as a feature, but I always have to remind myself, oh, it's doing this. Okay. Okay. I will fix that. Okay. So that's the export. Now, So that's variables and how to use patterns to manipulate variables, okay? Now, we need to consider the what is a shell script, okay? So a shell script, we know it's a collection of commands, but let's look at the structure of a shell script. So a shell script, you can run them without this, but they really should always start with the line like this, the so-called shebang line, okay? Hash, exclamation mark, /bin /bash should always be the first line of a shell script that you write, okay? The reason that it's there is because you'll notice that it starts with a hash. The hash in the world of the shell is a comment character, okay? So in other words, the shell will ignore anything after the hash character, okay? But that means that the shell is ignoring this line. So for whom is this? This is not for the shell. This is for the Linux, not for the user either, for the Linux system, okay? If you actually look inside Linux, okay, then I'm dumping in a more easy readable way 2 commands, okay? Notice this is bash. This is how bash starts. This is in computerese, okay? But it starts with this value, 45.7f, okay? 46.4c. Notice that this other command, cat, that does a totally different thing, is starting with the same pattern. So when you try and, what makes a program to Linux, okay, is that when you run it, Linux knows how to run it, okay? So binaries like this, bin, like bash and cat that I've just shown, they have a binary marker, okay? And you can ask, there's a program called file, and file will explain what it says. It'll look at the so-called file, looks at so-called magic numbers, which is the patterns at the start of the files, to identify what type of a file it is. And that's why your hash exclamation mark /bin /bash has to be the very first thing in the file. It can't be on the second line, can't have a space in front of it, has to be the very first thing. Okay. Then you can obviously, sorry, not obviously, I can't use that word. You can run a command. If I look at, I've got a, if I make a script, I can run these commands using the bash program. Okay, so I can go bash space and then the name of my script, okay? What's going to happen is that bash will read that script. It will understand what I've written there because they are valid commands for bash, and it will run them, okay? But there is more. If I want to run that thing directly, in other words, if I don't want to tell bash to run it, but if I want to tell the Linux system or the Mac OS system to run it, then I have to do 2 things. I've already got the correct start to the script, and I say, but the other thing is I need to make it runnable, otherwise known as executable. command a plus x test dot test dot to test dot sa test one dot sh. And if I now look at test one dot sh, it now shows that it's got all of these x's, which means that it is a runnable script, okay? Of course, if I want to run it, I need to tell the system where this thing is, okay? That's what the path is for. The path environment variable has all the places where, when I type a command name like cat or ls, it will go look for a command, okay? To run it, or bash, whatever it is, okay? So if we want to know where something is, it will go, if we want to run something, it will go look at all these different places. But if I don't have my current directory is not in that list of places, okay? I'm in home data. There's no home data in this list of things. Yes, I could change the path. So normally, we'll maybe make a bin directory slash, $home/bin. We'll make a directory where we put all our scripts. Then we can add that to the path. Then it will automatically find any scripts that we put there. But I'm not going to get involved in that right now. I just want to run what's right here. And I do that by just referring to the name of the file. And then it runs it just as if I told bash to run it. But here is a text file. This text file is executable. Let's try and run it. You can see that those are not valid commands. But not just that. If I try and run it with bash, bash will say command not found. Okay? If I try and run it with like that, what says command not found? I had exactly the same thing last time. I can't remember how, but in a certain, I remember exactly this thing. I thought it would say that it doesn't know how to run it. But obviously not today. I can't remember exactly how why I think that this is a shell script. But okay. But anyway, it's not valid shell script, but you must have that thing at the top, the hash bang, to tell it, like, run this thing with bash. If you're writing a Python script, you put a different thing at the top there. If you're running an R script, sometimes you can run R scripts that you run on the command line, you put a different thing at the top there. They always start with the hash and the exclamation mark, what is known as shebang. But what it tells you is which tool must be used to run this thing, okay? And this, in this case, it's a shell script. We run it with bash.
And if you take the executable right,
If I take the what away?
executable rights.
Okay. Then we get this. Oh, sorry, wrong thing. Test one. Permission denied. Okay. So even though the file is perfectly fine, it's got the correct commands and everything in it, if it doesn't say X, I am not allowed to run it. Okay. This is just a safeguard thing that Linux is doing. So you have to make it. And when I do this, I'm saying everybody can run it. You notice there's X over here, user, group, everybody can run it. Notice it's also readable by everybody. That's also necessary. It has to be, bash must be able to read the script to run it. Okay? But normally just saying a plus x is fine for our purposes. I don't want to get into the whole stories of Unix permissions and how Unix permissions work. Okay? That's its own topic, and it's not super complicated, but it's definitely is its own topic. Okay? that's what a shell script looks like. How does shell script relate to the command line? Well, via parameters, okay? And I know I'm going over some of the same content that I've taught before, but I just want to make sure everybody's on the right page here, okay? So, sorry, the wrong window, this one. Just copy this code. The special variable $hash always contains the number of parameters that you passed to the shell script, okay? So here I said /test1.sh 1, 2, 3. So there's 3 parameters. In the shell, parameters are separated by spaces, right? So if I went back to that command, it still says 3 parameters, right? Because this thing in quotes is a single parameter, because I've used the quotes to group it together, right? And then I said echo $1, echo param2 $2, and because I'm using it like that, okay, then it pulls out the parameter based on its position. $1 is the first one, $2 is the second one, and so on and so forth. Okay, and that's, I've not made any use. The third parameter, I'm not printing it because I didn't put any code in there that uses $3. Okay, you don't know how big those numbers can go up to. I haven't tested that, but anyway. Can you do like 100? I don't actually know. But anyway. So if I edit this file, or if I run this, no, if I keep the file the same, but if I just give it one parameter, then number of parameters 1, and you see here it's not an error, but param2, there is no $2, okay? There's no second parameter, so it's just blank. Okay. So now, you can change how your shell script works with a few flags. And these are set in your shell script using the set operation, okay? Set isn't a command, it's an instruction to bash how to interpret the script, okay? So, let me illustrate a few of these things. If I say set -e, then there is no command called no such command, okay? If I say set -e, my shell script will stop as soon as there's an error. Typically, I'll just change the script because typically we put these options at the top of the script. Now let me just make a copy of the script. Copy test1.sh, test2.sh. If I take away the set minus e, just check that, copy the. Now if I run test2.sh, it still gets an error, there's no such command, but it carries on to the next line after the error, okay? So set minus e stops if there's an error, okay? Why is this useful? Well, sometimes if one thing goes wrong, then it's a signal that like more things are gonna go wrong later, okay? So typically we use set minus e in our scripts to say, look, if there's a problem, fail fast, rather than wasting all your time and perhaps doing the wrong thing by carrying on and carrying on and carrying on, okay? That's set minus e. Then set minus x turns on debugging, basically. It shows you what the script is running as it runs. So if you say set minus x, then you can see here in the plus lines, it shows you what the command is before it runs the command, okay? So if you're not sure what your shell script is doing and you want to trace it, then set minus x, okay? Another way to do that is to just run the script with bash space minus x and the name of the script, but the same thing, okay? And one last one, I have one more in the notes, but I'm just going to leave this for here, minus u. Notice that when I used $2, it was undefined, but the shell didn't really mind. If I set minus u, then that means using an undefined variable becomes an error. And you see here, now instead of printing nothing when it gets to the line where it was referring to $2, it now ends. It says unbound variable. What it really means is undefined variable, okay? So if you want it to be an error that you try and use a variable that doesn't exist, then use set minus u, okay? There's another one that I mentioned in the notes called pipe fail. And what pipe fail is about is that when you combine, like this morning, we had all those pipes, you know, tail, pipe, salt, pipe, unique. But what if something goes wrong in the pipes, okay? So pipe fail basically says, if any component of the pipe fails, declare failure. Don't try and carry on, okay? Which again, it could be quite useful, and generally is useful. So these are different ways to change your shell script behavior. Okay. So now, loops. Remember, I want to download all of these files, okay? And I'm going to download that using the for loop. There's actually, I discovered on the weekend, about 4 different types of loops in the shell, okay? This is the one that I almost always use, what I call the for each loop, okay? So for loop var in, and then you've got a list of things, okay? And then what you want to do in the loop. Actually, if I can get the attention of the experienced people, I would like to test this one. I think it's like so. Yeah, no, do. Let's do the, oh, that one. Oh, I'm missing a bracket here. Who from like George and John and all these kind of people knew that we could do C-style loops in Bash? where you use I is equal to 1, I let, like if you've written C programs, this will look familiar to you. I don't know, I've been using Bash for like years, and I didn't know that I could do that. But did you know that you could do that? Nobody. C, Java, you can do these things. Did you know that you could do this in Bash? I've been using it for years, and now I discovered I'm not gonna don't focus on this thing, but because this is like not what we would normally do, but I was like amazed that there's new things that like okay. So in the materials I've linked to the carpentry's lesson on for loops. But I want to illustrate a few things that are going to make for loops more useful, okay? Because you've got that thing that the for loop is working with a list. But where do you get the list from? Okay? And this is where another thing comes in useful. And that is the dollar round bracket. So, take, for example, seek110. The command seek110 outputs the numbers from 1 to 10. Okay, this is a Linux command. Don't think this is a bash command. Yep, seek is a Linux command. Okay, you can do it with skips and 1, 2, 10. They're the odd numbers. Okay, you can do all of those kind of things. Okay. So how do we use this in a for loop? If we use it in a for loop, we want the value that the command, we want to get access to the value that the command generates, right? And how we can do that is by dollar round bracket. So if I say my var is equal to dollar round bracket, and then the command that I'm running, it is better. It's not as cold for people, right? This is the man to. This is our boarding manager. Do you want it warmer still? It's still cold at the back. These guys are from warm countries. Can we start a fire here? Between the two sets of desks, we'll just set a fire up there. Now, when we moved in here for the first time, this was all open. None of that cubicle stuff existed over there. All we had was these tables. And then we didn't, just had like the extension leads going everywhere. And somebody tripped the whole Borden's electrics because they put a heater in. They plugged the heater into here somewhere. So yeah. But anyway, you can't do that, but there you go. Anyway, so if you take dollar round bracket, it takes the values, okay? And it gives you that back, okay? Now the trick here is that list is separated by spaces, okay? So let's look at our test.txt. It's these words, right? So for loop var, I'll just carry on calling it loop var for a bit, in $cat test.txt do echo hello loop var. What am I doing wrong? I forgot to close the quotes. Okay. I'm putting it all onto one line. I'm going to show you guys just now, when I write it in scripts, it splits across lines, okay? But this, I'm using these semicolons to put it all on one line, okay? So here, it runs 10 times, once for every, it looks like it's running once for every line, okay? Let's change this file. just to illustrate, 10, 11, and 12 are all on the same line. Okay? But when I run this thing, it runs 10, 11, 12, all as if they are on their own line. Because what's happening here is that whatever the output is, any space, whether that's a white space is so-called, what we call white space. So it could be tabs, it could be spaces, could be new lines, is used to separate the different things that you're going to loop over. So for each, and a bunch of things separated by spaces, okay? You can actually change that behavior. I'm not going to get into how to change that now, okay? This means that you can, but this dollar round bracket means that you can do a huge amount, because now what we can do is take one command and use it as another thing to for another command to kind of connect them together, but not like using pipes. A different way of connecting things together. And you can put a whole pipes and things inside of that dollar round bracket. Okay, so let's have a look at that. Let's take an example from this morning. Pipe, grep, months, sorry, tail months in +2. Okay. Pipe cut minus eliminate the comma minus field 3. So here I've pulled out all of the dates where we had a case involving an infant, okay, under age 1. And now I've taken the complete multi-part pipe, and because it gives me some output, I can now loop over that output. Okay, so I can put just about anything inside of those round brackets. So long as it gives me a value, so long as the program will finish, won't ask for user input, and will give me a value which I can then loop over. Okay. Now, I've been using a variable called loopvar over here. It can be called anything. You choose the name of the variable. It's just that it's lining up. Call it loopvar over there. Okay? Just so if I want to call this var, but I don't change the other one, what's going on here? The same value over and over and over and over and over again. Why does it show that value? So what it's showing here, last time I used loopvar as a loop variable and I set its value, it had this value 2015-02-19. Now, because I don't use loopvar over here anymore, let me illustrate, okay? If I go echo loopvar, the value will be what when I 2015-02-19, okay? Because when the loop finishes, the loop var, whatever you call that variable, will be left carrying the last value that it had when the loop was running, okay? That's why loop var was not undefined, okay? But when I run this thing, it runs for as many times as there were things to run for. Okay? So you see it still run many times. But because I did not coordinate the variable name here and the variable name there, this was never being updated. So I must always coordinate the variable names, okay? In that place for the variable name in, and then whatever I call that variable must be how I call that variable, okay? Just something to pay attention to. So if I correct my error here, then we see all of the different dates. Okay. So that's the essence of loops in the shell. Okay. Now, let's get back to the problem at hand. How do I download a file from the shell? This is the thing. There's not one solution for this one. I found two very common commands for this. But what typically do I use to download a file from a link in the shell? wget, yes? wget and curl. So there's two commands. The reason that I know these two commands is because some people's computer has wget, some people's computer has curl. So some people have both. I've got both, but not every computer has both. Okay. So how am I going to download all of the files that are mentioned here? All of them. I'm going to use a loop, right? That's why I'm talking about loops. I'm going to use a loop, okay? So let's start writing the fetch command. Do I have the fetch command already? I will delete my old one. And I'm going to give you parts of it, and you're going to help me fill it out. For, and I'm going to call this line in, and I'm just going to make this very simple at the moment. I'm going to call this do done. Okay? No. When I loop over this thing, I get a line, okay? Because that file, and just going back to what it looks like, the file has lines that look like this. To make our life simple, there's no spaces in the file, but the lines look like this, okay? Which is the bit that I want to use to actually fetch the file. After the comma, okay? It's column 2. Huh? Column 2. Huh? Because at the moment, this thing I don't care about. The ID on the left-hand side, I don't care about, okay? So, I want to cut out and only get column 2, okay? So that means that I've got a few options here. The one option that I've got is that I can retrieve the line, the whole line, using cat, but now I'm going to have to do something to split the line to get the URL out, okay? How can I improve this script to, instead of getting the lines out, only get out the URLs, the links which I want to download? That's great. Is cat the right tool for the job here? Why you say no? I see people thinking, but think with words. What is cat giving me? The entire line by line. Why is cat splitting this thing up into different parts? Because there's some white space. The end of line at the end of the line is splitting this thing into the first line, the second line, the third line, the fourth line. Okay? But I don't want the line. I want the link. How can I get just the links from the file? Let's leave the script for a moment, okay? I want just the links from the file. Cat. Yes? So now, remember that instead of getting the lines, I want the links. Cat. Okay, how must I make my cut?
Cat minus D.
Cut minus D, comma, minus F2, 5, what was it called? File is 1 at here. So if I do that, now I'm only getting the values in the second column, which is the links, the URLs, okay? So I'm now going to go change fetch.sh. So now I'm going to say URL, you know the term URL, right? It is a link, okay? Cut minus D, comma, minus F1, so F minus F2, sorry. Okay, so now I'm going to do something, okay? What am I going to do with this, okay? Now I'm going to wget it, but with a few options. I'll show you both the wget and the curl options, okay? The thing is this, when I go wget, okay, wget can choose its own name for the output file. I don't want to do that because sometimes wget chooses a name I don't like, okay? I want to decide what the output file name should be. So now, let us look at what a link looks like. Long line. But looking at this long link line, I want the file name to be this part. Over here. The piece that I've highlighted. I want that to be the file name. Okay? That is why I taught you about manipulating the value in a variable. We can use one of those patterns. So let's experiment. Okay? Shell scripting is a very experimental thing. You do a few things, you see what works. Okay? Just like working in the lab, except you can actually see what you're doing. You're not moving clear liquid from one tube to another. So let's say URL is equal to, and I'm going to give it, I'm going to give it one of these values. Hey, this is not, let's go back here. So if we say $URL, and is it this one? And this is where I start experimenting again. Nope. Start slash. Yeah, then. If we say URL 2 hashes start slash, it will then, the pattern will eat up everything until here, leaving me with simply the file name part of the URL. Okay? And as you saw, I experimented with the pattern. I knew that it was something about hashes and stars and slashes, but I worked around. Okay, and I figured something out. Okay. Now that I've done this, I'm ready to do version 1 of the script. But I'm going to tell you why version 1 is not going to be my final version just now. wget minus C. Whenever I use wget, I almost always use minus C. Minus C to wget means if you've got a partial download, continue. If you don't use minus C, if you download a second time, it will download a second copy of the file and just call it something .1, okay, or .2 or whatever it is, okay. And then minus O, big O, and then dollar output, and then dollar URL, okay. Minus O, write the output to this thing, okay. And where must I fetch from? This thing, okay? Up, ls minus l, fetch.sh. It's not executable, cat fetch.sh. It's got the shebang line at the top, chmod a plus x fetch.sh. I typed something, that is the behavior I wanted to show just now. No such file or directory. This is a confusing error message, and it is why it has to be explained, okay? There is a file called fetch.sh. We just saw that there was a file called fetch.sh. What does this mean? And I'm actually wondering why I got that error message now. Just checking. Oh, it's getting a notice file directory from this thing. What did I call the file list? .csv, not .txt. That's why. Okay. Now this shows the weakness of this script, okay? I've hard-coded the file name into the script, okay? Easy way to make mistakes. Instead of, and I'm going to move away from that, okay? And I'm going to illustrate something else. I'm going to set minus u, no unset variables please, set minus e, if there's an error message, please exit straight away, and I'm going to say list file is equal to $1, okay? So the first parameter when I run fetch is the list file, okay? Now I'm going to make my user's job easier using an if statement, okay? Allows me to illustrate if statements. If minus f $list file, then, sorry, if not couple of points here. This if statement in bash has this syntax that after if actually comes a command. So that thing with the square brackets, it's not super obvious, but there's actually a command called square brackets, okay? What that command is, it's otherwise known as the test command. And the test command lets you run various tests. One of the most common ones is -f. Does this file exist? Okay? And if I say -f, the file exists, then exclamation mark -f means the opposite. It means not exists. Okay? I will link to some resources on understanding these things because there's so many different little knobs that you can do here. But then if it doesn't exist, give me a nice error message.
What if it's missing? Should it be incorrect or missing?
Okay, incorrect, or no, it's like file name is incorrect or missing.
You're the person out of train.
Yeah, writing good error messages, it's a discussion. I'm not going to get into the psychology of that. Although, by the way, if you guys are using Python, huh, I would definitely recommend upgrading to at least Python 3.10 because they've made the error messages so much easier to understand in Python 3.10 compared to older versions.
What's the if I?
Where?
Just below that.
The structure of if, like do goes for something do and it ends with a done that you can't see. The if ends if something then if I. You can also have else and things like that, but let's not get there right now, okay? So you must say if I to say this is the end of the if, okay? If I is kind of like end if in other languages. This is if I run it without, this is not a nice error message. I have to write other things in there to get nice error messages. If I run it without a parameter, I get this unbound variable, undefined $1 because I haven't given it a parameter. Now if I give it this, what I did before, right? I made a mistake. What should happen if it can't find things here? It should exit. Because you see what happened is it said incorrect file name, but it still carried on trying to do its thing. Okay? So that's why when it said cut, then this was not found, but that error message is because down here I said list file instead of $list file. Okay. Now I get the error message. File list 1.txt not found. Because we know it's a CSV. Put it all together. And what did I do wrong on line 17? Why did it echo in here? I don't know, it must be sleepy or something like that. I did have a little bit of an energy drink this morning, but by the way, Zambian energy drinks are something else. If anybody here has not been to Zambia before, I don't know if it's like I don't know if it's the same in your other countries, but here my chosen energy drink that I drink is called Score. Okay, in Zambia the energy drink will be called like Rambo or Combat or like Victory or something very dramatic like. You know, we're not going to go in here doing bioinformatics. We're going to go and win a whole war or something like that. I don't know why the Zambians are like having this thing, you know? Does it work? Do they work? I bought for my kids the Black Panther energy drinks to try those, you know? I think I did try it. Yeah, it worked. It kept me awake there in Lusaka. I think I had a combat or something. No, it doesn't help with memory, no. But I hope that like some of these other places have a more peaceful name for their energy drinks, you know? like not like, you know. I think it's all working now. Ta-da! It's now downloading, okay? It's tested, does the file exist? It's got the code right and things like that. I'm not very happy with the script, okay? For this reason, what would happen with the script if one of the downloads silently failed, okay? You know, the thing is that, like, yes, we can keep running the script until we can keep running it over and over and over again until we're satisfied that we've downloaded everything. Who here works in a lab that has bad internet? You know? It's like almost all of, like, yeah, most of us, right? You know? So your internet can fail, all sorts of funny things can happen. So maybe you could run it and run it and run it and run it until it succeeds. But there are better ways to do things, and we'll look at them just now, okay? But before we do that, let us examine our file holdings. Obviously, these are not full-sized files, but looking at these files, what can we do to quickly look at these files to get an idea as to whether we think the files are okay? What's one of the first things that you should check with your files once you've got them out of the sequencer? The file size, okay? So we've got the file size here. How can we sort this list from biggest to smallest? I used the -H when I did an ls -L, but let's make it raw. How can we sort the file size from biggest to smallest? Or smallest to biggest, just so long as it's sort by size. This is our output. How can we sort it? Which one is the size? Nope, that's the dates that I downloaded today, the 4th of March. After the user, that's actually the group.
Before the dates.
No.
Before the dates.
Yes. No. Yes. Yes.
Yeah,
Okay, this is the file size. Permissions, this is the number of links to the file. User, this is the owner, this is the group that owns it. I am in group user 50. File size, date, name. Okay, great. We've identified where the file size is. How do I sort based on file size? If I just did this thing, let me show you something that will not work. That doesn't work. Actually, it did work. Why did that work? Well, this worked because everything here to the left is all identical. Okay? But in general, this wouldn't work if there was different like bits and pieces there. Okay? What should I do with sort to actually make it specifically sort on this? What do we call fields in sort? This morning we were talking about sort. Good, you remember the two flags, but you didn't remember exactly what they're for. You remember there's a T and you remember there's a K. What does -T do for sort? T is the delimiter flag, okay? What does -K do for sort? The key. What is another word for the key? It's your column number or your field number, okay? So sort -K is our column number, okay? And what else must we remember? N. So which is this? The default delimiter for sort is white space, by the way, so we don't need to set -T. Okay? But 1, 2, 3, 4, 5.
So -K5.
and does give the same results, but whatever. Let me reverse it just to make it there. Okay? In R. Okay? LS minus L pipe sort minus K5N or K5NR. Sometimes you just remember things like, you know, they talk about muscle memory. You know, like if you've seen a toddler walking, you know, you see how walking is a learned skill. Okay, but now if I walk, I can walk backwards, I can walk forwards, I can walk sideways. And I mean, this is because walking is falling, right? Walking is an organized way of falling. I'm going to fall and then catch myself. That's anybody watches a toddler, they'll know what I'm talking about, right? But you just remember it. And like sort minus K5N, I'll probably be like sitting like an old man in a nursing home, and you'll ask me, what's the sort command for sorting by file size? And I'll remember sort minus K5N because it's so ingrained into my head. Like the names of my children. I'll probably forget the names of my children first before forgetting this. Okay? Great, people. What do we say about the data now we've done this? Are we happy with all of our samples? Just give it an eyeball. Get a sense for the smell of the data, okay? What I mean by the smell is, does it smell good? Does it smell like this is right? Or does it smell like there's something wrong here?
We should first know what data it is.
Okay, but these are all from the same bacteria, okay? They're all from the same. Tracy says something about the last ones. Remember, they come in pairs. 1, 2, 1, 2, 1, 2, okay? So in general, we've got about 120K for these files. A bit over 100K. This one is 90-something K. But look at those last two over there. Less than 40K. Okay? So immediately, just looking at the size of our data, we get a sense there's something wrong here. By the way, I've learned to emphasize this because, you know what? Us bioinformaticians, we don't get respect. Okay? They just want the result. But sometimes I get this from the lab. And I say to these guys, guys, you guys did something wrong. The sequencing reaction didn't run properly or something like that, okay? I have a colleague, I won't mention their name or their country, who specializes in contaminated data sets. No, I am not joking. Who here works on Mycobacterium tuberculosis? Come on, who works on Mycobacterium? Yeah, you see, the only sensible person in the room. Okay. You know? So, Mycobacterium tuberculosis, before you sequence Mycobacterium tuberculosis, what do you do? In the lab. In the lab, do they just put it in a tube and sequence it? So what do you do?
So the wet lab,
Yeah.
what they do mostly is they get maybe a small example of it, and they deal with the setup. They use a setup method.
Mm-hmm. But before the CTAP, they grow that thing, right? They normally culture that thing in an MGIT tube or something like that, or they culture it on a slant or something like that, okay? Which means that by the time that you do a CTAP, your Mycobacterium tuberculosis is meant to be MTB. That's one of your sample. Then my colleague comes to me with samples, 30% human in the sample, okay? Another one, I looked up what she had 30% of some bacteria that is known to colonize the human gut. And I'm like, guys, do you not wash your hands or wear gloves or whatever before you're doing your lab work, you know? Because like this is not right. You're meant to have pure culture, you know? Other ones, and I understand this, people come to you, they say it's this organism. Now you try and try and work with it and it doesn't give you the right results, then you discover it's not that organism, it's something else. You know, they picked a culture from the plate, and they picked something. They picked something that's like superficially similar to what it's meant to be. You know, so as bioinformaticians, we have to learn our biology and be very thorough in our quality control, because good results require a close and trusting relationship between the bioinformatics and the lab. Okay. Which means why I started saying that we get no respect. Because when they just want us to take whatever and run whatever, which is why as bioinformaticians as well, even if you're coming from a computing background, you must learn your biology, you must learn your lab. Not that I'm saying I've never held a pipette in my life in a proper way, okay? But I know what's going on there, because good results are a conversation between the different people and in the equation, because you need to collect the sample right. You need to, my colleague here is working on the epi side. You need to collect the metadata right. You need to collect, and when I say right, if you're going to make it difficult, if you're going to make the life difficult for the clinic nurse who's dealing with 100 patients a day, you know, and if you're going to make life difficult for them to collect that data, you are going to get sloppy data, okay? Or you're going to get missing data, whatever it is. So that must be right. The sample transport must be right, okay? Which I know is challenging in many of our countries, because the clinic is far, the road is bad, you know? All of these kind of things, okay? Sample transport, then to the point of storing in the freezer. You guys who've been in South Africa, you've experienced the joys of what we call load shedding, right? Where the power just, okay? Now, in most of our African countries, we have equivalents of load shedding, unless you're in Namibia, you know, where you get lovely South African power and no load shedding, okay? But you know, like most places, you don't have load shedding on a schedule. Like I can look on my phone and tell you when is the power going to go off, okay? It's just, there's the power gone, okay? Then you generator kicks up. But what if, you know, maybe the generator tripped, or somebody didn't buy diesel this month, or whatever it is, and now your freezer is starting to defrost and all of those kind of things, okay? Or whatever, you haven't hit preserved cold chain for other reasons, okay? Now you're getting your sample is degrading. All of these things feed together. And bioinformatics is a part of the whole team, which just needs to be accepted as part of the team, and not as seen as the magical people that they can make gold out of straw, you know? Anyway, this is just a speech that I'm giving, because I know this is my tribe here, but I'm just saying that when we go back to our labs, that I've seen this problem that, like, if it's not being done as a team effort, then quality suffers, okay? And I mean, like, George, I know you guys, when you were dealing with, like, next door to you in a country which I won't mention, okay, they were using the same nanopore sequencing technology as you for SARS-CoV-2, and they were not able to get good results. They were like, nanopore, it's a terrible system, okay? But in George's lab's hand, in Kerry's hands, they nursed it to beautiful results, you know? I'm not saying that it doesn't have challenges, but I'm just saying that, like, this learning the different ins and outs of the tools, you know, it works as a team on a team system. And this is also why it's incredibly important that we need to build a better communication between everybody, because then when we don't know, why is this yield so low, okay? You know, nanopore sequencing of SARS-CoV-2, I'm not talking of mycobacterial tuberculosis. When people here around me have told me, okay, the read length is maybe 2-3 kilobases because breaking the mycobacterial cell wall was like fragmented DNA. I've got colleagues who are getting 10 kilobases more routinely because they've optimized protocols for that. Yeah, George.
So sorry, I just wanted to get into your teaching a little bit, because I think it's important, but I didn't want to see by a show of hands maybe how many of us work in isolation, like if you've never been to the lab.
You've never been to the lab?
The wet lab.
Yes. Never been to the wet lab?
Like you've never stepped in a place where people have lab coats and big cars. Yeah?
Papa say. And
And how many
but
of
you
us work with people or process data from people who actually are in sort of the wet lab? Yeah. So, so my challenge to you is to take off 3 days and shadow the people for whom you are analyzing data from.
But not just the wet lab, also the clinic where the patient form is filled in.
And it's really important for the reason that Peter has mentioned. Because unless you know how those data are generated, the challenges sometimes that can come with that, it's only then will you appreciate that you're not a god. Right? And you can do magic. Because working together with people, you look at the entire process, but also they also gain an appreciation when you tell them that there's no QC that's going to correct rubbish data. And there's nothing, there's exactly what Peter is saying, like, you've been given rubbish data and you're supposed to work out some magic and get a consensus to it's not going to work. The same way, you can't be on the computer and banging your hands and say, they are giving me rubbish data. If you don't actually understand how those data are being generated. The challenges, sometimes in some of this data, is it can be a simple miscalculation with the pipette.
Yeah, but it can also be a sample that came from 300 kilometers away.
Yeah. So they've all been changing, and then for some reason, procurement says, and doesn't communicate, that they've changed the vendors for pipette tips. And now everybody is using a different brand of pipette tips, and they've been giving you good data. And all of a sudden now you have rubbish data. And now who do we blame? The lab people or procurement? But those are real life scenarios. I just want to ask how complex it can become, and the need to, appreciate the entire data process, exactly how the data came out, and to be really, how do I say, like, really
cognizant of the process.
Yeah, like understanding it's one process. It's the same thing, and you've got your stake in how those data are generated. So, an example is in our lab, all the bioinformaticians do spend time. It doesn't matter whether you computer science, but we will send you to the lab for 2 weeks. You don't have to stay there, you don't have to live there, but we will send you there just to understand and to work with those things. And then you can.
But I think this is also why automation is incredibly important.
But I think
That the analysis is always done the same way and it has QC at every step.
but
No, Tracy?
not to. I think it's more the other way around. It's the lab people don't appreciate the bioinformaticians. I think more that we are told it should be so simple. You just welcome to just do this in one day, you do something.
Who was I talking to? There's somebody we had that conversation. I think it was with John, who also has got a lot of experience. And often as a bioinformatician, that's it's good that you highlighted that. Is that it's always like giving a script. Oh, all this is all it takes. And then before you know it, you have 15 projects, each of which is asking you a script, a data tool, or something.
And they never shadow us.
Yeah,
Because
yeah.
it looks boring.
Yes, and then
But we must shadow them. I'm not saying we should have this
But they can't shadow us.
Other way around.
The problem is they can't shadow us. I mean, my colleagues out there who do the media, they sometimes want to make like photos of us and doing our work. There's nothing to take a picture of because I mean, I come from a computer science background, and they say computer science is like building or developing software is like building a bridge that you can't see because you never see the thing. You see the end result. Did the car crash into the valley? That you see, okay. But you never see the bridge, the gird, the pillars of the bridge, and the iron, and all of those things, okay. You don't see that.
We don't see the DNA either, but we don't.
No, but in but I think it's not true to say in the lab you don't see the DNA. Yes, you do not see the DNA. Yes, you do not see the DNA, but there's a physical. That's why I think it's important to kind of go in the lab. What are people doing? Because the thing is this, like for me, if I watch somebody working at Pipette, they're like, and like, what? But if you understand their thinking and mental process and how they keep it organized, you know, that this is the protocol, we're going from here to here, this is what we're doing to reduce contamination, this is what we are doing, this is the, here's our SOP, you know, that we have developed, you know, because they might, I'm not talking about like the students, you know, here that we are just learning this thing, but a proper lab is having an SOP.
We can also say this is how we're doing QC.
No.
And then
Yeah.
show them. So I think
No, we can, but we, and I think that this is where we can. But this, we can't visualize what's on our screens most of the time. What we can show is, this is my QC. This is the results that I'm getting. This is why we need to visualize, because we must make the bridge visible, right? We must make the invisible visible, because otherwise, like you run the whole thing. This is our problem with automated systems, right? Yes, we must automate to scale. But my problem with automating the whole system is that at the end of the day, you get this nonsense. And what happened? You know, I remember the one time, and I mean, it's my fault. I tried to run some of the data through an automated system. The whole system crashed, and because the QC hadn't flagged it and stopped the process early on when there was a problem. Okay, and so there was a big controversy over the use of a technique called UMAP in human population genetics recently. And it's a very interesting conversation around that. I asked my colleagues what in our microbial field is the equivalent. And the best answer I got is our databases. Okay? So people would take something and they will compare it against the database and they'll say the database says this. Okay, I happen to know that there are mislabeled samples in the databases. Things that are labeled as Vibrio cholerae, they're not. A good example is the amount of contamination that's crept into the databases. So, for instance, brucellosis, okay, it's an important agricultural disease, okay? But it's, if some of the bacterial assemblies, because of how the samples were collected, ended up having some bovine DNA mixed into the assembly, okay? Which meant that, like, because that's from cow, okay, the sample, if you then run it through the analysis and you take a sample from a cow, okay, then it shows that this cow has a disease because the cow sample is matching to the cow part of a disease sample. And if it's something like that, you know, this is serious disease that you have to report to your veterinary authorities and things like that. It's because the database was dirty, you know. So there's so many things to learn and to get on top of, and yeah. But also why the problem is much bigger than I feel like any of us, and so, you know, sharing experience. And the other thing is, the other thing that I feel is part of this thing is a certain discipline amongst certain scientists that don't want to be wrong. You know, and it's difficult when you're learning to you know, Tracy as well, and myself, like, because we both come into this thing without a formal like background in you know, maybe all of the microbiology and things like that. There's some people who basically like are finding fault all the time, and they make it so that you can't be honest about like your doubts, you know. So that's a community thing that we need to work on. That like you will do something, you'll get wrong results. Doesn't mean that you're an idiot, you know. Anyway, let's finish off this script and my complaints about the script. So also we need to wrap up the day. Okay, and I've been logged out. User 50. One of these windows has my password in there. Okay. So I'm going to delete this downloaded data. The thing that I was saying earlier is, how do we know when the download has succeeded correctly? Okay. So now I've used set -e in my script, which meant that if a download failed, it would give an error, and the script would probably fail. But I've got another trick I want to show you that I find quite useful. Okay, I'm going to make a folder called tracking. And now what I'm going to do is, if
Yeah, like this.
what? The TV. Why is this thing like so?
What do you think?
So I'm just going to save this and make another. I'll give you this code a little bit later. Sorry, let me do this to TMP like that. Move. Okay, so what does this all do and what is this all about, right? So sometimes you need a flag that you've done a job already. So I made a folder called tracking, okay? So I can go change the code at the top here, if not minus the tracking oh wait, no, this one is, this is, I'll leave out this thing on TMP. Okay. So I'm making a tracking folder. And if I don't have the tracking folder, then this thing at the top here will go make the tracking folder for me. Okay. And what this thing does is, if there isn't a file with the same name as the output file in the tracking folder, then go ahead and download this thing. Okay. Once you finish downloading, touch just makes an empty file with a particular name. Touch the marker file name, okay? So what this means is that the second time around, if you already downloaded this thing, the tracking files will be there already. And then you won't need to re-download it. This will stop you, this will keep track of how many files have you completed downloading, okay? So even if your job crashes or something like that, it will start where it left off, because we're using this tracking folder to keep track of things. Okay?
Excuse me, Peter, I have a question.
Yeah.
So you're creating the output file. You're telling it where to do it, or in this
Yeah, I'm telling it there.
or in the whole.
Okay. So I'm putting it, it's actually happening in the current directory. I could put it in a different directory, like say reads or something like that. But I'm doing it in the current directory, okay? I just want to show, if you're using code, I'll comment it out, but the equivalent command, I'll have to look up the equivalent for -c with code. Code equivalent. Okay, I'll have to look it up. Okay. I'll have to find the -c equivalent. But anyway, so if I basically, so code writes things to the standard out. Okay, So normally you would say something like curl$URL greater than $output. But I'm going to look into the -C equivalent for curl as well. But that's the kind of approximately equivalent curl command, okay? Where's my, fetch. Then of course file list. So now that's going to go download everything. And I mean, I've written these kind of fetch scripts many times over, fetching things. And I've learned through trial and error to like check these to do this kind of checking, okay? And once it's finished, we'll see what. Hopefully, we'll see what that if statement does. And I've just remembered while that thing's running, I just want to quickly put something in place. I'll just copy it from here. Just now. So now that you've downloaded it, look what happens next time I run it. It looks like nothing is happening, right? But let's have a look at what's in tracking. And what I've used this for in the past is if I have a file that's not downloaded correctly, I can just delete the tracking file. And then when I run it again, it will re-download it. So I can use the tracking as a control for whether it knows whether more work needs to be done. Okay? So if I want to see what the script is doing, instead of running with -X, you can see that it's actually running all of these commands, but it's just if -F this, and then of course it finds it, so then it moves on. Okay? If not -F. One minor thing, I'll mention it in the on the web page when I update it tonight. Sometimes you see single square brackets. Bash has the double square brackets. It just has a few more features than the single square brackets. Okay? And in one last thing before we are done for the day. Just going to give everybody a copy of this file. And then so the stuff's been downloaded, but is it the right files? Okay. Sometimes downloads can silently fail. If you're lucky, the people who are giving you files also have a checksum file. Okay. A checksum file looks like this. It's a long list of like these things called checksums, and then the file that it's computed from. Okay. So what a checksum is a special number computed from the file. This checksums is computed using something called SHA 256, which is the most common thing used these days. You might also see a thing called MD5, okay? And so I can use this command with the -C option to check if these files are okay. And it says, okay, 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 and then it warns me that one of them failed. And I can try re-downloading it, and I can guarantee you it will fail again, because I've deliberately made this file not match the checksums, okay? If this happens, you go to the person, if you've checked that your downloads are done perfectly, you go to the person who you're downloading from and you say, do you have a corrupted file on your server or something like that, okay? The reason that I've learned recently to rarely do this is because I ran a whole analysis and I couldn't make sense of some results. And I went back and I checked the files against their checksums, and I saw that this was not a clean download of the file, okay? So I'll put all of the stuff about the shell scripting online. Shell scripting, the if statements, the for loops, very useful. They can make your life a lot easier. This morning you've seen lots of different commands that can help you in different ways. Use the tracking folder as a way to track long-running tasks, you know, something that runs for a long time, okay? Also, choose the right tool for the job. Shell scripts are fine. Don't make your whole bioinformatics workflow into a big shell script. There are better tools for that job these days, and you will learn from some of my colleagues later this week about some of those better tools, okay? So, yeah, don't rely entirely on shell scripts for everything. But yeah, remember, learn about checksums and how to use those to preserve downloaded file integrity. Okay, so that's been quite a bit today. Any questions before we end for the day? Does everybody still have their stickies with them? Because everybody, for this last task I give you, everybody needs the green and the yellow sticky note. Okay?